Okay, last week we talked about solving systems of linear equations. How did we solve them? What were we just doing on IXL? Graphing, right? Using the slope and the intercept to graph it and then figure out where they cross or if they cross, right? Okay, so today we're going to do this without graphs. This is all math, no graphing, okay? So first we need to know what the substitution method is. Okay, what does it mean to substitute something? Take something out and replace it with another thing. Usually we have like a letter and we're replacing it with a number, right? Today, we're substituting one expression into another. Anybody remember what an expression is? Substituting one expression into another in order to solve. You do need to highlight that. Okay, so write down this example. Guys. Write down the example. Okay. We want to be able to take one thing and substitute it into the other in order to solve this problem. So if x equals 6y and x equals 5y plus 20, what do we know about both of the second parts of those expressions or equations? If they're both equal to x, then they're equal to each other. They're the same, right? So instead of saying x equals both of these things, I'm going to take x equals 6y and say 6y equals 5y plus 20, right? Both equations are equal to x, so they have to be equal to each other, right? Questions about how we can do that? Does that make sense in your heads? All right. So then we're trying to solve this for y because that's the goal is to write an equation that only has one letter in it, right? Because if it has one letter, then we can solve it. Okay, so if we want to solve this for y, I got to get y by itself. So what do I need to do to solve this for y? Subtract the 5y from both sides. Because it's a positive 5y, we want it to go away. 6y minus 5y is 1y, or you can just say y equals, what's left on that other side? 20. You could divide by 1, but it's the same thing, right? So y equals 20. So that part's done. We have y. Now we need to know what x is because we need to have a point where they cross, right? So we have y, we need to find x. How could I find x? If I know y is 20, what can I do with that to find x? 20 times 6. I can plug it back into that first equation. Does it matter which equation we use? No, right? They're equal to each other, so it won't matter. But I don't want to do 5 times 20 plus 20, right? I want to do 6 times 20 because that's easier. Okay, so we're going to do x equals 6 times, and since we know y is 20, you substitute 20 for y. What's 6 times 20? 120. So at what point does this graph cross? 120 is the x value, right? So is x then y, and y is 20. So 120 comma 20 is the solution. That's the point where these two lines cross. Now, would you have wanted to graph this? No, that would have taken forever, right? 120, 20, we don't even have that many squares on our paper. Substitution is much easier when you have smaller numbers. Sometimes graphing makes sense because it's little numbers, it's quick, it's easy. Substitution, when the solution is going to be off the graph, this is way easier to do it, right? Okay, let's try another one. Okay, number 2. X plus 2y equals 12. X equals x equals y plus 3. Okay. So normally if I say like x equals 10, I just take that 10 and put it back in the problem, right? Same idea, except now we've got to take y plus 3 and put that in for x. So we're going to take this problem up top, x plus 2y equals 12. We're going to find y. Okay, all I did was copy the problem from the top line. Okay, I know x equals y plus 3. So instead of writing x, I'm going to take y plus 3 and substitute it in here. Okay, so y plus 3 plus 2y equals 12. So everybody see how that happened? So that makes sense to us. Not hearing any objections. Okay, so then what can I do to try and solve this? They're on the same side, right? So we can just add 1y plus 2y would be 3y plus 3 equals 12. All right, so now we need to start moving things around. What am I going to do first?
Divide 3 by 3.
Not yet. Subtract the 3. That one goes away. 3y equals, what's 12 minus 3?
9.
Okay. Then what do I need to do?
Divide.
Divide, because we're solving for y. So we got to divide by 3. Y equals 3. Okay, so I have y. I need x. Which one of those equations makes more sense to solve for x? The bottom one, because it's an x equals, and y is what? 3, so replace y with 3 plus 3. What's 3 plus 3? 6. So what point does this graph cross? 6, 3. Good. The other nice thing about substitution is you don't have to make it into slope intercept form before you start, right? You can just start. Let's try one more for today. All right. Y equals 2x plus 5. And y equals 4x minus 13. Okay. If I want to solve this, how would I go about setting this up? They're both equal to y, which means they're both equal to each other, right? They have to equal the same number. So the two parts are equal. So 2x plus 5 is equal to 4x minus 13. anytime it's like the same letter, so like x equals or y equals for both problems, you could take the two other sides and set them equal to each other. Okay, so now, where did what come from?
Oh.
Okay. Okay, so now 2x plus 5 equals 4x minus 13. How are we going to solve this? Okay, you could start with the x's or the constants, right? Ava said add 13, so we'll start with that because it doesn't matter which order you do it in. Okay. All right, 5 plus 13 is 18, so 2x plus 18 equals 4x. Solving for x because we replaced all the y's. Okay, so then how am I going to combine the x's? Subtract. Subtract the 2x to the 4x. So 18 equals 2x. And then I have to, good, 18 divided by 2 is, so there's our x. Okay, we need to find y. X is 9. Does it matter which one of those I pick? No, I always pick the one that looks easier to me, honestly, like save yourself some work, right? Let's do the first one because adding is usually easier than subtracting. Okay, y equals 2 times what's x? 9 plus 5. Okay, what's 2 times 9? 18. And 18 plus 5 is 23. So what point is the solution to this problem? 9, 23. Always x first, right? Okay, we are going to be done with notes for today.